Chapter 3, States of Matter. We're going to cover Section 1 and 3 today. Section 1 is about solids, liquids, and gases. So all solids, liquids, and gases are classified based on their shape and their volume, and whether that is definite or variable. A solid has to have a definite shape and a definite volume, so your desk, your pencil, your notebook paper. It's not saying that it can never be changed, but the current state it's in is not changing. Liquids is a definite volume but a variable shape, so it will take the shape of the container it's in. And gases have a variable shape and variable volume, so you can shape the container, compress, or expand a gas. So gases move in many directions. They will fill the container of any shape or size, and they are going to be moving very, very quickly. Liquids are going to be contained close together. They're going to be on a constant movement. They're going to move or mold to the shape of the container, but again, they're going to be really close together. They're not going to spread out or move in every direction. And then solids, they're moving very slightly. They're on a fixed location. So these are very orderly, very packed together. Section 3, phase changes. Phase change is a reversible physical change that occurs when you have a substance going from one state of matter to another. So we have melting, freezing, vaporization, condensation, sublimation, and deposition. Now, a couple important factors are temperature. The temperature itself in a phase change is not changing, only the state. So for example, at 32 degrees Fahrenheit or 0 degrees Celsius, water will either freeze or water will melt or ice will melt depending on which direction the temperature is moving. But only at 32 degrees will it melt or freeze. Energy is also a big factor in this. Energy will either be absorbed and taken in or released during a phase change. Now, melting and freezing, we all know what those are. That's when you have the arrangement in molecules become less orderly as the water melts, so everything kind of spreads out. And then they become more orderly, or they stick together and hook onto each other as the water freezes. So ice cubes taken out of a freezer, or if you put water back into the freezer. Now, vaporization is from a liquid into a gas. So, for example, boiling water. That's vaporization. However, there's a difference in vaporization and evaporation. Evaporation is from liquid to a gas, but at temperatures less than boiling point. So this is when you have a cup of water sitting out, and maybe after a week you come back and half of it's gone. Now, water in a closed container will act differently. If you have a lid on a container of water, that water, once it evaporates, will gather on the lid and form water droplets in condensation, and then will fall back into the actual container. So you won't be losing any water at all for that one. So we have evaporation, we have condensation, which is the opposite, so going from a gas to a liquid. So think about water collecting on the outside of a glass. That would be condensation. So you can see that here in this image of water droplets on the outside of this soda can. Last two, sublimation and deposition. Sublimation is where we go from a solid to a gas directly. So there's not a liquid phase for this. So it's kind of skipping a step. Sublimation, think about dry ice. That goes from a solid to a gas without changing into a liquid. And then we have deposition, and deposition is the opposite. You go from a gas directly into a solid without becoming that liquid first. So think about frost that you may have on your vehicles in the morning. That would be a gas, which is water vapor, directly into that ice or that frost, which is a solid. And that's it for this chapter.